Hi everyone, let's take a look at the following example. Find the antiderivative or the integration of sine x to the power of 2 with respect to x. Step number 1, before we find the antiderivative, think about the following concepts. And these are the concepts that were taught to you from this other course called MHF for you, also known as Grade 12 Advanced Functions. So, if you need a refresher, here it is. You go back and you think about the double angle formulas. And I'm thinking specifically cosine of 2x. Now, there are three ways to express this. And we're going to use one of them in a moment. But I do want to give you a refresher just in case you want to go back and we activate these skill sets. One concept is to express cosine 2x as cosine x times cosine x minus sine x times sine x. So that's the first way to express this. A second way to express this is to rewrite this as 1 minus 2 sine square x. And again, I hope you can see this because if you really think about cosine square x, you can express that as 1 minus sine square x minus this sine square x, which will give you 1 minus 2 sine square x. Likewise, you can also rewrite this as 2 cosine x squared minus 1. And again, the reason why this makes sense is because sine square x is 1 minus cosine square x in brackets. And when you take cosine square x minus 1 plus cos square x, you get exactly this back. So again, that was the refresher of the three concepts that you can reactivate here and now. Now, we go back to this. Let's use a different color again. We're looking at sine square x. We're looking at sine square x. And the question becomes, can we make this connection? And the answer is yes. Of course, you can make this connection. And here's how. So let's kind of go back and show you how to connect them. Now, all we have to do is from here, again, cosine 2x equals to 1 minus 2 sine square x, which means you can bring negative 2 sine square x to the left. That's going to be 2 sine, let's try again, 2 sine square x, which equals to 1 minus cosine of 2x. And of course, the opposite of multiplying by 2 is to divide by 2, just like that. So what that means is I can go back now and make this connection. I can cross that out. This is the connection I'm making. Let's go back to the original blue. There we go. So this is going to be the antiderivative of 1 divided by 2. Notice I'm expanding it as two different parts. Minus 1 divided by 2 times cosine of 2x. And again, we're finding the antiderivative of this entire expression with respect to x. Let's put brackets just like that. Now here comes the final answer, and I hope you're with me. The antiderivative of half is basically half times x. And likewise, if you think about the antiderivative of half of cosine 2x, the antiderivative of cosine is going to be sine. So you can write down sine 2x. But don't forget, you have to divide by the derivative of 2x. And the derivative of 2x is going to be 2. And since there's already a half at the front, this means it's going to be 1 divided by 4. Again, think about the fact that you're looking for infinite many cases, also known as family of solutions. So you have to add a constant c, where c is an element of real numbers. Now again, at this moment, I would like you to try to double check this on your own. What that means is you have to find the derivative of half x minus a quarter sine of 2x plus c. If you do it right, you should get this expression back, which means you get exactly the question back. Now, I will go through it right now, just through a dialogue with you, and you can copy all the notes down on a piece of paper. So again, when I find the antiderivative, when I find the derivative of half x, that's going to be half. So this gives you half back. When I find the derivative of negative 1 divided by 4 sine of 2x, Again, when you differentiate sine of 2x, that's going to be cosine of 2x times 2. The 2 in the negative quarter will give you negative half back, and cosine of 2x is exactly what we were looking for. Of course, the derivative of a constant is going to be 0. And now you go back to this, which is equal to sin² x. I hope this makes sense.